Welcome back, everyone. So please complete your warm-up. What is the difference between experimental probability and theoretical probability, okay? So we've been finding all of these different probabilities, either experimental or theoretical, and we can show the probabilities in what's called a probability model. Now sometimes this is a chart, sometimes it's a bar graph, different things like that. A probability model shows the sample space of outcomes, events, and the probability of those outcomes and events. The first model we'll learn about is what's called uniform probability, okay? So uniform probability means all of the outcomes have an equal probability. So when I roll a die, I have equal opportunity to get a 1, 2, 3, 4, 5, 6. There's nothing weighted, okay? And like I said, in theoretical probability, this would be flipping a coin or rolling a die, okay? In experimental probability, usually nothing's equal because we can't predict it. It could come up at any time, okay? But theoretical probability, lots of stuff is uniform. So Ben randomly selects a counter from the group of counters below. Now you guys cannot see the colors because when they copy it, it's black and white. So the first one's yellow, red, blue, green, black. If you really want to look in your book in 10.4, you can see the picture in color. He then records the color of the selected counter. So we're going to define the sample space. Remember, sample space is just all my outcomes. So I have yellow, and I'm just going to shorten these, red, green, I guess I don't really have to shorten them, blue, and black. Okay, and I kind of did those out of order, but, so yellow, so I don't have to write it. Should have just wrote the whole word, but oh well. Okay, so what is the probability of selecting a counter of a particular color? Well, I can choose any one of these colors, so one color out of 5 options. Okay, so there's a 1/5 chance of getting yellow, of getting red, of getting blue, of getting green, of getting black. Okay, now on to the next page here. So the different colors, I have yellow, and the probability is 1/5. I have black, probability is 1/5. I have blue, and the probability is 1/5. I have red, and the probability is 1/5. And I have green, I think was the last color here. It's 1/5. Okay, and then use the bar graph to show the probability distribution. So this is one type of probability model. Then the bar graph, so I'm going to have yellow, black, blue, red, and green. And they're all up to 1/5, right? So I have 1/5 and maybe 2/5 just to show the difference. I'm going to have a bar for each little guy here, right? All at 1/5. So this shows my complete sample space. Just shows the probability of getting each kind, okay? So on and so forth. Pretty easy. My next one here, I have a list of names. So Liz, Taylor, Brett, Gabe, Laura, Natalie, and Delaney are students. A teacher randomly chooses one of them to answer a question. Explain why a uniform distribution describes the situation. So I have an equal chance of pulling each name, right? Because there's 1, 2, 3, 4, 5, 6, 7 names. And if I put them all in a hat, I have an equal chance of getting each one, right? Of getting each one. Okay. So what is the probability that Gabe is chosen to answer the question? So it'd be, there's one Gabe out of 1, 2, 3, 4, 5, 6, 7 names. So 1 out of 7. The probability of, or if A is the event of choosing a girl, find the probability of A. Now remember, there's 7 total names, right? And getting a girl, so I have Liz, Taylor, Laura, Natalie, and Delaney. So it's 1, 2, 3, 4, 5. So I have 5 out of 7 chances of getting a girl. Okay, that should be pretty easy. We've been doing that for a while. Your exit slip, a number is chosen at random from this list. Explain why a uniform distribution model describes the situation. Have a wonderful day. We'll talk to you tomorrow. Bye-bye.